Okay, now we are on number 13, and we are again going to do number 13 by slide and divide. So I'm going to take 27 and multiply it by -5. So I get a squared plus 42a minus 5 times 27 is 135. So I'm going to look at my factors of 135, -135, that add to be positive 42. So I'm going to skip and jump right to -5 because 1 and 2, clearly they're not going to work. And 135 divided by 5 is 27. So that's a little bit too small. So maybe let's try, because that sum's going to be 22, where I'm looking for 42. Let's try 135 divided by 3, -3 times 45. Oh, that adds up to be 42. Check, that's what we want. So I'm going to go ahead and say that this factors to a minus 3 times a plus 45. Since I multiplied by 27, I have to divide by 27 and simplify my fractions. These are both divisible by 3, so I get a minus 1/9 times 45 and 27. They're both divisible by 9. A plus 5/9. So then when I go ahead and I put it together, I'm sorry, this is a 3. Oh, sorry, that's my 9. This is my 3. So when we put it together, you swoop up your 9 and you get 9a minus 1 times swoop up your 3, 3a plus 5. You can go ahead and check that and it will come out to be right. And you get 9a minus 1 times 3a plus 5. For the last one, again, let's do it by slide and divide. So slide your 4 over, and you have x squared minus 16x plus 60. Oh, well, two things that multiply to be positive 60 and add to be negative 16. How about negative 10 and negative 6? This worked out nice. Divide by 4, divide by 4. Simplify those fractions. They're both divisible by 2. We get x minus 5 over 2. These are also both divisible by 2. X minus 3 over 2. So then swoop up your 2's and you get 2x minus 5 times 2x minus 3. And again, you can check by doing your chapter 7 distribution. For number 15, it says determine whether each value of c makes this factorable, yes or no. So you have to just try it out. So if c is negative 15, so for c equals negative 15, go ahead and do 5x squared minus 22x minus 15. Try that by slide and divide times 5. X squared minus 22x minus 15 times 5 is going to be 75. So then, let's see two factors of negative 75 that add to be negative 22. Well, that works out kind of nice. How about negative 25 and positive 3? Since we split 5, we divide by 5. And you get simplified x minus 5. 3/5 is already simplified, so 5x plus 3. So did it factor? Yes. What were the factors? X minus 5 times 5x plus 3. Let's try c equals 8. So we'd have 5x squared minus 22x plus 8. So let's slide our 5 over, and you get x squared minus 22x plus 40. Oh, two things that multiply to be 40 and add to be negative 22. How about x minus 20 and x minus 2? Negative 20, negative 2, positive 40. When you add them, you get negative 22. So now divide by 5. X minus 4, 20 divided by 5 is 4. 2/5 is simplified, so you get 5x minus 2. So you have x minus 4 and 5x minus 2. So yes, it did factor. The only way to do it is by trying it. Determine whether the trinomial is a perfect square. Remember, it has to fit the form a squared plus 2ab plus b squared. This can be a positive or a negative. It doesn't matter. So the first thing you should check, is n squared a perfect square? Yes. Is 36 a perfect square? Yes. So now I just need to check my middle term. My middle term would need to be 2 times the square root of n squared times the square root of 36, because a would be n squared, b would be the square root of 36. So you get 2, the square root of n squared is n, square root of 36 is 6. So you get 12n. Is 12n the same as 72n? No. So is this a perfect square trinomial? No. My explanation is the middle term should be 12n. Or you could say it's not factorable. Let's try number 17. Is 9x squared a perfect square? Absolutely. What is the square root of 9x squared? You could even say a equals the square root of 9x squared, which equals 3x. b would be the square root of 25, which equals 5. My middle term would need to be 2ab. So let's try it out. 2 times 30 times 2 times 3x times 5 gives me 6 times 5 is 30x. But this is a negative. Oh, well, the square root of 25 could also be negative 5. So we get negative 30x. Yes, that is it. So then remember, your factorization would just be 3x minus 5 squared. So yes, and it's 3x minus 5 quantity squared. Could you have done this by slide and divide as well? Yes, slide and divide works. If you would have done this by slide and divide, you would have gotten the same answer, and you could have worked backwards then. To tell whether a binomial is a difference of two squares, the first thing, it has to be subtraction, and you have to have a squared minus b squared. If so, factor it. If not, explain. Is p squared a perfect square? Yes. Is 132 a perfect square? No. So no, it's not, because 132 is not a perfect square. Let's try 19. Is 16x squared a perfect square? Yep. What is the square root of 16x squared? Well, that's just 4x. Is 49? Yep. So that square root of 49 equals 7. So yes, it is. And when you have a difference of two squares, you have a plus b times a minus b. So this one would be 4x plus 7 and 4x minus 7. Because remember, a is the square root of the first, b is the square root of the second. If we know that the area of a square in square feet is represented by, I know that the area equals 4z squared minus 36z minus 81. We need to find an expression for the perimeter. Perimeter is 2L plus 2W. Then find it when z is 10. To take the area and find the length and the width, we know that area equals length times width. So we have to factor this. We need to find the two factors. One factor will be length, one will be width. Let's do this by slide and divide. So times 4. So we get z squared minus 36z minus 81 times 4 is going to be 324, which seems like a pretty big number. So let's go ahead and let's list some factors. So negative 324. Let's see, negative 324 divided by 3. So negative 3 times 108. Not going to work. 324 divided by 4. Negative 4 times 81. That does not add to be 36. 5 is not going to work because it doesn't end in a 5. 324 divided by 6. Negative 6 times 54. Well, negative 6 plus 54 is 49. We're getting closer. Let's try 324 divided by 7. That doesn't work. 324 divided by 8. That doesn't work. 324 divided by 9. Negative 9 times 36. Well, that's not going to work. Actually, this is a positive 81, positive 324, positive. So we just have to make these both negative, 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 and you ended up adding them together. Still doesn't work. So I keep thinking, keep going through my factors, and I get negative 18 times negative 18. Well, that does work. So I have z squared minus 18 times z minus 18, not z squared. Since we multiplied by 4, we have to divide by 4 and simplify. So we get z minus 9 halves times z minus 9 halves. Flip up my 2, and I get 2z minus 9 times 2z minus 9, which since they're the same, it's 2z minus 9 squared. But I don't really care as much about that because I know that this here is my length times this is my width. So when I plug it in my perimeter formula, I know that P equals 2L plus 2W. So 2 times 2z minus 9 plus 2 times 2z minus 9. Go ahead and distribute, and you get 4z minus 18 plus 4z minus 18. 4z plus 4z is 8z. Negative 18 plus negative 18 is negative 36. So that's your perimeter, which is in feet. So your expression for your perimeter is 8z minus 36 feet. And the last part, when z is 10 feet, you substitute it in. So 8 times 10 minus 36. So you get 80 minus 36, which is 44 feet. So this is 44 feet. Again, since this was a positive 324, we had to find two factors that were negative that added to be negative 36, and that was my negative 18, negative 18. We did our slide and divide, then we used our perimeter formula, and then we substituted it in. This was a pretty big problem. Just make sure you're careful too when you are substituting numbers in.